And we're still in domain 3. We're just wrapping it up. We've got a couple more sections here, security engineering. Now we're going to consider site planning. As the name implies, how do we plan our sites with security in mind? The single most important goal is planning a site is protection of life, property, and operations. Probably in that order, I would guess, hopefully. And our goal is based on comprehensive security assessments of our threats and hazards. So planning and design countermeasures are appropriate and effective in reducing the vulnerabilities and the risks to our organization. There's a natural conflict between making a facility convenient for operation and maintaining the secure facility. But isn't that always kind of the natural conflict when it comes to security? Right? Ease of use versus secure operations, and there's always that trade-off. That doesn't change when we're talking about facility designs and securing a facility. Convenience and accessibility is considered during the phases of design, but the requirements for security should not be sacrificed for convenience. Just because somebody doesn't want to go through a man trap because they're claustrophobic or whatnot to gain access to a facility doesn't mean that you shouldn't consider that as one of your securing principles. We have to make sure that we implement proper security controls to reduce the flow rate and ease of entering and leaving a facility. If you guys have ever been around any type of physical entrance to like a military installation or government installation, you know that gaining access to that facility, with a vehicle should not be, a straight line, so to speak. So the gate at the front of at the entrance to the facility has the roadway makes you go through various S turns or the entrance, the physical entrance to the building is offset, 200 yards from the parking lot. So you have to walk down this big, long sidewalk to be able to get into the building. Those are, we don't think about those things in our environmental design. But when you look at secure facilities, those things there's actually, we'll talk about that in this section. It's called CPED, right? Crime prevention through environmental design, where you're actually, with the design, the natural design of the elements of the construction, you're adding layers of security. I'm not talking about like putting in bollards and stuff like that. Just, don't have any windows on the first floor. Make sure that there's not a direct roadway access or perpendicular roadway access to the building, or, the roadway itself is not, somebody would not be able to get up to 80 or 90 miles an hour on the roadway and still be able to access the facility because, they could break through barriers or bypass security and so on. So if it's a brand new construction, it's kind of easy to address those and to facilitate those considerations. Looking at different egress points, what the administrative requirements are for controlling those entries and exits. I mentioned this actually, roadway design. No facility has, this is not a very well written sentence, but no facility has no roadway access, right? Just every facility is going to have some sort of roadway access. Now, it doesn't have to go necessarily right up to that facility, but, we're going to have a parking lot. We're probably going to have a roadway to support vehicular traffic because that's how we transport each other around. The idea of streets are not thought of as ways to curtail unauthorized access or to prevent sabotage. Streets are generally designed with convenience in mind, reducing the amount of travel time, reducing the amount of congestion and traffic, maximizing safety, but also ensuring that the layout is efficient and so on. So like the grid system for a city or the street system for a city or a highway system is going to be more for convenience than for security. Maybe the most efficient course, designers should consider a roadway system to minimize vehicle velocity, using a roadway as a protective measure, right? That's exactly what we were just talking about. Instead of having direct access to the facility, maybe we have to go over speed bumps. Maybe we have to make various turns to get past to the gate, whatever it might be. Straight lines or perpendicular approaches to the facility should not be used. That gives the vehicle the opportunity to gather speed, to ram, or to penetrate buildings. I know it seems like kind of a dramatic statement, but it is a huge concern. Let me rephrase. It is a significant concern for facilities that are secure, like a government facility and so on. Think about the Unabomber, right? Bombing that Oklahoma City building. The roadway went right up next to the building. So he didn't have to access the secure facility, a secure parking lot, or anything to park the U-Haul van with the ammonium nitrate and the bomb or whatever. And that's why that attack was so successful. Parallel approaches to perimeters of buildings, natural earthen berms, high curbs, trees, separating the building from the roadway are important. Yes, you can have barriers and bollards as well, but in this country, not as much in some of the countries around the world, but in most modern Western countries, we still try to design facilities so they don't look like prisons. We try to design facilities so they're somewhat pleasing to the eye, and they don't, people want to be around those facilities or want to work in those facilities. So having all of these physical barriers and barbed wire fences and whatnot aren't necessarily what we need, but we need protection systems in place that will substitute and kind of provide the same level of protection, but is secure. So when you guys are kind of moving around now, I don't know if you've done this before, but when I look at facilities, from time to time, I'll kind of evaluate, especially after I've just taught this class, I'll look at a facility and say, oh, okay, so that makes sense why those boulders are there, or that makes sense why they planted a bunch of trees there, or they should put boulders there, or they should put some trees there, or whatnot. Just something to consider in the design of our facilities. It's not just having a fence, You go to the Caribbean or you go to other places, and they're not as concerned about aesthetics. It's funny, I was in Trinidad and at a facility, and it had a brick wall around the facility, and then all they did is they just put some wet concrete on top of the brick wall and broke bottles and just jammed shards of glass into the concrete, and that was their additional security, so somebody wouldn't climb over the wall. I guess that's somewhat effective, unless somebody just puts a blanket over it, I suppose. But aesthetics were not a consideration in that instance, I guess. Although nowadays that might be considered art. Anyway, crime prevention through environmental design, CPTED, is the agenda for manipulating the building and built environment, the neighborhood or the facility or whatever it might be, for safety. All right. And it encompasses many things, things like natural surveillance, access control, the what we call the broken window principle, that, if you see an area that is high crime area, you'll see a lot of buildings and a lot of damage to property and whatnot. And that actually tends to invite more crime, right? So the idea is that if you have good property maintenance and you assert visible ownership of a particular space, that it's less likely that you're going to have crime. So you have to have appropriate environmental designs that increase the perceived likelihood of detection or apprehension of criminals, which would be at least a deterrent factor for crime, right? There also have been renewed interests in interior design, making facilities look a little bit more aesthetically pleasing, and so on. So imagine, if you will, that you have a school, right? You have a school that was built in 1950s. It was totally utilitarian as far as the design goes, and it didn't have a whole lot of aesthetic consideration. It's more likely that type of environment would be vandalized or damaged or destroyed than a modern school that might use modern building techniques, where we use nice, pretty, pristine construction materials. We have artwork, and we have just aesthetically pleasing designs. It could significantly affect somebody's decision to make to vandalize. So other considerations for CPTED: planting trees, planting shrubs, eliminating specific escape routes. Obviously, lighting would be a big consideration. And then also considerations for things like pedestrian traffic, bicycle traffic, and so on. So it's not just the for building the environment for aesthetically pleasing reasons. It's we have strategies to influence decisions that a potential offender might make. If they're going to commit some sort of criminal act. And this is based on research of criminal behavior, and the decision to offend or not to offend is going to be more influenced on something that would identify the perceived risk of being caught. Like, for example, if you go into a department store, and Target is notorious for this, right? Go look at a ceiling in a Target. And there are literally hundreds of camera domes in a Target department store. But you might go into some other department store and there are no camera domes. What's the likelihood that somebody, unless they're just bold and brazen, what's the likelihood that somebody would, whether those camera domes are effective or not, doesn't matter. It's the visual perception, right? If I was a shoplifter and I go into a store and I see hundreds of camera domes, that would most likely give me the perception that I have a higher likelihood of being caught than one that doesn't, right? It doesn't mean that would be the case, but and being caught always is going to be a deterrence for perpetrating crime. Also, it's not the severity of the crime or the punishment. It's just the idea that you might actually get caught. So CPTED-based strategies kind of emphasize enhancing this perceived risk of detection and apprehension. It includes things like natural surveillance, design streets to increase pedestrian and bicycle traffic, so you have more people that could potentially see you. Make sure you have windows and whatnot that overlook sidewalks and parking lots. Maybe even window shades are left open. Use passing vehicular traffic as a potential for surveilling the environment. Create your landscape designs that keep surveillance in mind, especially in proximity to points of entry or opportunistic points of entry. We talked about years ago building the border wall, and there was discussion of, should it be a solid wall, should it be a rail fence, whatever, and it made sense. We're going to design a wall that provides for penetration security, but also provides for adequate visibility to see not only what's happening on our side of the wall, but what's happening on the other side of the wall. All right. Use the shortest possible or least site limiting fence options. That's kind of where that sits. As long as it's appropriate for that particular design. Use transparent weather vestibules, maybe. Or when we're creating our lighting design, make sure that the lights are placed in an adequate location so that we don't have blind spots. Maybe we have, specific areas of traffic that are highly lit, like pathways or stairs or parking garages or by ATMs, mailboxes, etc. Also, it's important to avoid security lighting that's too bright, which might create deep shadows or glare, or it might hinder the view of a security camera, and so on, especially at nighttime when you have such severe lighting differentials. Using a lower intensity light might be more appropriate, but then you might also have to install more fixtures. Maybe you have shielded lights or protected lights that stop the glare as well. Use curved streets. We talked about that with multiple viewpoints and so on. We also have natural access control mechanisms. Make sure that we have single points of entry or at least limited points of entry. Those points of entry are clearly identifiable. Structures that might be put into place to divert people from sensitive areas. Maze entrances. We talked about that with regard to vehicular traffic in a military installation. Avoid kind of isolation, if you will. Use bushes that might be aesthetically pleasing, but they might have natural protection barriers in them as well. Thorny plants, I wouldn't say necessarily poison ivy or poison oak, but something that if I walk through could provide some sort of natural protection. Obviously, we talked about a couple of days ago that art heist where they went on the roof and triggered the alarm and whatnot. So avoid access to roofs. Use picket fencing or some sort of fencing that is at least waist high. There's all kinds of considerations that we could have, right? I could just go on and on and on, but I think you get the idea. All right, landscaping is important as well. Trees, signage. We're going to avoid things like chain link fences and razor wire because actually, it's kind of a good point. You have a fence with a chain link fence with razor wire and whatnot. It is relatively secure, but it also kind of gives you the idea that maybe that's the only level of protection, that there's not any physical personnel there or physical presence of any personnel there to actually protect the area. So I could go on and on and on, but the idea is that we are using the construction environment to protect the construction of the environment to protect the environment itself. All right. Avoid elements that create a poor image, a fortress-like appearance. Include security, but treat gates, grills, barriers as public art. Make the perimeter fences look attractive, allowing visibility through the fence, including a simple design motif, in combining with maybe a hedge of a thorny shrub, and so on. Mentioned that previously. Use different grades of toughened or laminated glass as a design alternative instead of having bars on the window. Yes, bars on the window tend to be a little bit cheaper, and they're pretty effective, but they don't look very good. And aesthetics, at least in this country and in other countries like this country, aesthetics are a huge consideration. Businesses are encouraged to direct visitors through the entrance for contact with an individual to determine the purpose of their visit and to authorize them and authenticate them, have appropriate sign-in and sign-out procedures, ID badges, a communal area with a picnic seating where activities can happen is a good deterrent as well. Why? Visibility. You have eyes on the prize, so to speak. If you have an environment where nobody is around and there aren't people that can report on incidents or potential incidents occurring, that's going to maybe encourage crime as well. Windows are a significant part of any construction. Windows can be broken, which obviously makes them targets. Standard home installed glass windows break relatively easy. Window systems, glazing, frames, the anchorage of the windows can be used to mitigate hazardous effects of flying glass during things like damage or explosions or whatever. But we need to integrate the features of glass into our design, right? What type of glass am I selecting? What is the height of the window? If it does the window separate exposed areas from very critical areas? The windows should not be placed adjacent to doors where you can break the window and unlock the door. Laminated glass should be used in place of conventional glass with some sort of window guard, a screen or a grill. Now, that might not be aesthetically pleasing, but depending on the type of environment, it might be appropriate. Ground level windows should not have the ability to open and they should be protected with bars and or alarm systems. There are quite a few construction techniques now that make windows very, very secure, even without bars and other grills and whatnot. So that is something to consider. But again, it is about likelihood and impact, and it's about the cost ultimately, right? The cost of implementing these things can be an issue. So what are some different types of glass? Tempered glass is a type of safety glass. It's actually has various treatments, like thermal treatments and different chemical treatments to make it strong, and much stronger compared to normal glass. What actually happens is that the process of creating that glass takes the outer surface of that glass and it puts it into compression, and then the inner surface of the glass is put into tension. So when the glass breaks, it shatters into very, very tiny, small chunks instead of jagged, knife-like shards of glass that your standard annealed glass might do, right? Those granular chunks are less likely to cause injury. There was a an episode of Mythbusters where they went through and tried to test the potential damage of different types of glass, and it was kind of interesting. And sure enough, it was the annealed glass that caused the biggest damage, right? Tempered glass is used for safety primarily, but it also has different types of strengths. Obviously, in car windows, shower doors, aquariums, and so on, we use this type of glass. It is typically about 4 times stronger than your traditional annealed glass, and something to consider. You're not going to have to know those concepts that I just mentioned, right? The idea of compression and tension and so on, but understand at least what in principle tempered glass is. Wired glass provides resistance to impact from blunt objects because there's a wire mesh embedded in the glass, providing additional protection. You tend to see that a lot in older construction schools, right? The doors have wired glass in them, which you can literally see. Laminated glass is similar to wired glass. It is glass that has, it's also considered to be a safety glass, but it, unlike tempered glass where it shatters into millions of pieces when broken, the laminated glass will tend to kind of just stay together. There's a thin polymer interlayer, like a ethylene layer or a vinyl layer, that between the 2 layers or even more, right? We can have multiple layers of glass, and it keeps everything bonded together if the glass is broken. It prevents the glass from breaking up into these large, dangerous pieces. You might get cracking or shattering, but you won't be able to completely pierce the glass, so to speak. This can be used in high rises, in architectural design. We also see this with, if we're going to incorporate things like UV protection and so on, automobile windshields. Laminated glass can be used for things like sound insulation as well, because the attenuation compared to that monolithic glass that you would typically see, even it's double paned monolithic glass in a traditional home, is going to allow sound waves to pass through. Attenuation is the concept of loss, right? And that can be measured in decibels and so on. All right, bullet-resistant glass. Yes, bullet-resistant glass is a consideration as well. Now, maybe not as much in, say, building construction, although banks and other financial institutions, maybe jewelry stores and whatnot, might implement the use of bullet-resistant glass. But bulletproof glass is typically a lot thicker, anywhere from 3/4 of an inch all the way up to 3 or 4 inches. But typically these are going to be deployed in buildings that require lots and lots of security. Jewelry stores, military installations, and so on. So you're going to have composite layers of the glass, of plastic sheeting typically, and then layers of glass itself. The idea is that we're using different layers of lamination to provide more protection. The more layers, the more protection the glass might offer. So the aim is to make the material look like glass, right? Give it that clarity that glass does, but have effective protection against small arms fire. We use polycarbonate designs. The plastic laminates are pretty well constructed. And we have different protection levels that can apply. You don't need to know what the protection levels are. I think the protection levels go from 1 all the way up to 10. And then they measure the protection level based on the type of threat that gets stopped. So a 9mm glass or a 9mm shot might be protected at level 1, but if you're getting into like 30mm or 357 type stuff. I'm not a gun guy, so don't quote me on this, but like a 44 or a 357 would require a higher protection level. Okay, and it's going to depend on the thickness of the glass laminate, the thickness of the polycarbonate that's installed in the window, or if we're using some sort of acrylic or aluminum or whatever, transparent aluminum or whatever. And then, of course, there's a trade-off for that as well. As you add more and more protection, you're adding more and more weight to that glass as well. Just some pretty pictures of some glass. We see the laminated glass, the tempered glass on top, and maybe a representation of what bulletproof glass might look like. You would also want sensors in place. A good intrusion detection device for buildings with glass windows and doors is to have some sort of glass break sensor. Glass as an exterior protection barrier can be easily defeated depending on the type of glass it is. Several types of glass break sensors exist. We have acoustic sensors that listen for the sound of the broken glass, and we have shock sensors that look for that are attached to the window to feel for vibrations and shock. Actually, the best system would be the one that incorporates both, right? The acoustic and the shock. Dual technology is what that's referred to as. Dual alarm systems prevent false positives. Both acoustic and shock sensors would have to be activated before an alarm was triggered. Relatively inexpensive compared to everything else. And so implementing both would not be too much of an issue. It is a nominal component price of the overall installed cost, but it can provide a lot of benefit. It's not a preventative mechanism necessarily. It could be a deterrent. You see a bunch of sensors on a window or that can't be defeated by the foil of a piece of stick of gum. That can be a deterrent. All right. But it also can be a detective control. Natural location threats, something else to consider. The physical location of the facility. Are you going to be susceptible to earthquakes, floods, hurricanes, tornadoes, etc.? We have to prepare for those natural disasters. We have to have an adequate communication system and communication plan in place, keeping in mind that traditional communication mechanisms might not be available during the disaster. The way we communicate over cell phone or desk phone or whatnot simply might not be available. So we have to have backup communication plans. Information and periodic training exercises, fire drills, earthquake preparedness drills, whatnot, should be done as well. So people, it becomes kind of muscle memory, right? We're not having to think coherently in face of a natural disaster. We're just simply reacting based on our training. Organizations can reduce the impact of disasters by implementing flood proofing, installing emergency power systems, securing items that could shake loose during an earthquake or whatnot. All right? And we all know what, the natural disasters that we might face. Hurricanes, tornadoes, earthquakes, fires, mudslides, etc. Man-made threats from fire, whether it's some activist firebombing a facility because they don't agree with what they do, or somebody smoking and throwing a cigarette in a trash can, causing a fire, whatever. We know fire can be devastating. Fire can be devastating for many reasons, not only for life safety, but the flames themselves can be damaging, the smoke can be damaging, and the damage caused by putting out the fire, the water and everything else. I had a fire in my house, I don't know, maybe 10 years ago. The fireplace, there was a crack in the surround of the fireplace, and the heat and some of the embers got up into the wall, and I didn't even know. And I went outside to my backyard, and I saw smoke coming from the stucco. It's like, well, that's not good. So I went back inside the house, and I felt the wall above the fireplace, and it was hot. So my first reaction immediately, it was drywall. So I just started immediately, hammering the drywall and opening it up, and sure enough, the 2x4s were burnt, and I could see flames going up into the ceiling. So of course I called the fire department, and they came, but they're not concerned about whether or not they're going to scratch your hardwood floors or whether or not the hose is going to knock over, the priceless heirloom that you have sitting on the table or whatever. They come in and they put out the fire and they leave. And sure enough, I think there was more damage caused by the firemen than the fire itself. It was pretty crazy. Fire can cause damage in many different ways. Fire protection systems should maintain life safety. Obviously, that's our primary concern, and then property and assets would be secondary. Facilities, fire protection water system should be protected from a single point of failure. Incoming lines should be encased or buried, located 50 feet from high-risk areas, and interior mains should be looped and sectionalized. Looped meaning that the water can come from many different, kind of a ring type of scenario. Water can come from two different directions. Sectionalized means that damage to one section of the water system would not prevent other sections of the water system from functioning. Water can be the main fire suppression tool, but typically causes extreme damage, especially to electronic equipment. Yeah, no doubt. In data centers and whatnot, we don't tend to have traditional fire suppression systems. So fire extinguishers. In the past, they used to love to talk about Class A and Class B fire extinguishers, and what the difference was. But we still mention it as part of the discussion of what we do in class here. But honestly, I'm not sure that you really need to know what the different classes are. There are actually up to Class F in this case. A Class A fire extinguisher, and different countries have different ways of identifying. In most cases, fire extinguishers are going to be identified by some sort of color band or some sort of color sticker or something to indicate what its purpose is. In the United States, we do use colors, but we also use shapes and letters. So Class A is a triangle. You don't need to know that for the test, but that's for kind of ordinary solid combustibles. The mnemonic that you can use to remember that is A is for ash, right? ASH, just to be clear. Ash, right? So that would be, wood that's burning or whatnot. And then there's a numerical rating for that fire extinguisher to indicate how much liquid it holds and the amount of fire that it can extinguish. Sorry. The geometric symbol is A, and the color is green. A Class B fire extinguisher is for flammable liquids and gases. So like gasoline, kerosene, grease, The numerical rating for this fire extinguisher is the number of square feet that it can extinguish. Its geometric symbol is a square, and red is the color. And the mnemonic that you might use for that is B is for barrel, like a barrel of oil, right? So it makes it a little bit easier to remember. Class C is for energized electrical equipment. Appliances, circuit breakers. We never use water to extinguish a Class C fire because you'll get electrocuted. They do not have a numerical rating, and the extinguishing agent is going to be non-conductive in this case. The mnemonic that I would use for this one is C for current. Current being electricity. The geometric shape for this one is a circle, and the color is blue. I'm just telling you that. You don't need to know that necessarily for the exam. You might have to know, what types of extinguishers are going to be used in what types of scenarios. Okay. Let's see. Class D, combustible metals. In this case, things like magnesium, titanium, potassium, sodium, and its color is yellow. And the mnemonic that you might use for this is D for dynamite. Doesn't quite fit, but it is a combustible element, right? And the geometric symbol that we see for these types of fire extinguishers is a star. All right, these are typically found in chemical labs. They also don't have a numerical rating, and they're only designed for Class D fires. There is one that's not listed here, Class K. Typically, we see these fire suppression systems in restaurants and whatnot. The color for that is black. K is for kitchen because it's used for things like oils and fats, putting out oils and fats. And it uses a hexagon, like a stop sign, for its geometric symbol. The classification generally is the same for other countries. They're kind of the same. Fire extinguishers are usually obviously installed so that they're easily accessible, and there are certain requirements. It's interesting. My son had his school had a carnival this last weekend, like a carnival on the school grounds where they had bouncers, and they actually had full-size carnival rides like teacup ride and swing ride and stuff like that. But because it was outdoors and it was kind of a pop-up type of thing, there were a lot of generators running around the environment. So the fire marshal was on site and kind of walking around and required that every generator had a fire extinguisher next to it. So they had to run around and try and find different fire extinguishers, but they had to be appropriate fire extinguishers for that type of environment. Okay. We'll talk about dry chemical extinguishing agents a little bit later on in this section. Utility concerns. Security dealing with the electrical systems to guarantee essential power to the facility is important. Emergency and normal electrical panels, conduits, switchgear need to be installed separately at different locations as far as possible, as far as apart as possible. Electrical distribution systems should run from separate locations. Emergency generators should be located away from loading docks and entrances and parking lots. You don't want somebody running into your generator. You should have secure locations like the roof. Grades and interior areas should be protected. The main fuel storage for the generators should be located away from loading docks and roadways, entrances, parking lots, and then also, of course, the fuel itself needs to be protected from tampering, which surprisingly enough is not something that a lot of people take into account. This hotel that I'm at teaching this class has a generator, and I just happened to be walking by it, and I checked, and there's no security. I can open up the generator doors. I can get access to the spark plugs of the engine, and the fuel cell for the generator just has a twist-on cap with no lock. Maybe the likelihood is low that somebody's going to screw with that generator, but it's just something to consider. All right. Comms security is important as well. Communication is obviously an integral part of any facility. Primary telephone service, maybe PSTN, traditional POTS lines, PRI or a T1, or voice over IP. Or maybe we have multiple types of communication. So we're running a voice over IP solution, which ultimately is probably going to run over some sort of physical connection for data. But we might have backup POTS lines. POTS are plain old telephone system. Employees should be provided telephones, mobile devices, or radios, especially if they are in charge of emergency response and part of the communication plan. Base radio communication systems with repeaters need to be installed as well. And those base radio systems are typically going to be operated by guards or by management personnel and so on if there's some sort of breach in security or some emergency that we have to respond to. A lot of things we could talk about in this section here that's relatable to comms security, but for example, the MPO, which we'll talk about in the last section here, our point of entry, our facility point of entry. Is that area secure? Because if you're using traditional PSTN elements or traditional PSTN components, it would be very easy to take a butt set and tap into conversations and listen to conversations and so on. Utilities can suffer significant damage when subjected to shock or extensive environmental hazards. Minimize the possibility of critical failure due to these hazards by applying the following measures. Provide underground concealed protection of utilities. That can be an issue as well. If they're concealed, they could be damaged, unintentionally by somebody using a backhoe or digging or whatnot. That's kind of the old story that everybody tells when it comes to utilities security. Quick connects for utility backup systems if the redundant sources are not available. For example, at my house, I have solar, which generates a lot of power that I need for my house, but my solar solution did not include a generator or a transfer switch. So I installed my own transfer switch, and I just got a kind of a mobile Briggs & Stratton generator, and I can plug that generator into that transfer switch, flip the switch, and I can power my whole house off this mobile generator. But there's a quick connect piece, right? I just plug the generator in. I don't have to rewire anything. And it's just a matter of a toggle switch that I flip to switch from city power to the generator power. So that means I can be operational fairly quickly. Now, in businesses and whatnot, obviously that's going to be a little bit more automated, particularly businesses that can't have any downtime. Protect the drinking water supplies from waterborne contaminants. Manholes, clean out areas, the water main or water sources that come into the facility. Maintain routine water testing to detect waterborne contaminants. I would say probably most people don't do that. Or if they do, it's not for security purposes. It's just for, the general health and well-being of the individuals in the facility. Fencing to prevent unauthorized access to areas. So we'll use landscape planting to conceal potentially sensitive areas, but also fencing to protect them. Locate petroleum, oil, lubricant storage tanks and operations buildings, and make sure they're downslope from all of our other occupied buildings. So if there is a leak, if there's some sort of contaminant, it's not going to seep into the facility or anything that might be used inside the facility that would cause illness or death. Locate the fuel storage tanks at least 100 feet from the buildings, and utility systems at least 50 feet from loading docks, entrances, and parking lots or parking areas. All right. I used to tell people in this class, know those numbers, right? But frankly, in my experience, I have not seen them ask questions like how far away should a generator be from a facility, right? Those are the kind of questions you might expect to see. What type of lighting you have to use or what type of fire extinguisher you have to use. And quite frankly, there's just aren't any of those types of questions on the test. It really is, and I keep saying this, but it really is just a matter of interpreting the language of the question, which should give you a huge bump to your success in passing the exam. All right. We got another section. We'll move on to it